Assalamualaikum. So now we proceed to normal distribution. First, let's look at the introduction. The normal distribution is the most important continuous distribution in statistics because it occurs in many situations. So, the normal distribution comes from continuous quantitative data. Normally, we will use measuring device to measure the variable of interest. The normal distribution is a bell shape and symmetrical about the mean value. So the mean noted by mu. And then the curve, the two tails never touch the x-axis like this. Never touch the x-axis. So here, never touch. And then symmetrical. So this one is mu. The area under the normal curve is equivalent to probability with a maximum value of 1. So remember that the basic concept of probability value must be exactly equal to 1. So, if x is follows normal distribution, the probability density function is given as follows. Okay, so this one, the notation we use here is x is follows normal distribution. Mean equal to mu or known as the average value. And then this one is sigma squared. So sigma squared represents the variance of x. So since integrating the probability density function is difficult to handle, the standard normal is used. So standard normal here is x is follows normal distribution. This one mu equal to 0. And then the variance equal to 1. Then x is called the standard normal distribution or commonly known as Z distribution, Z or Z distribution. So the purpose of converting to Z distribution is to use the standard normal distribution table to solve the probability distribution problem. So we will use this formula. Z equal to x minus mu over sigma. So this one called as standardizing x to Z. Let's look at the standard normal table. So here is the calculated Z value, x minus mu over sigma. So Z refer on first column and first row. So first column, first decimal place. Second column, second decimal place. And this one is the probability value based on the calculated Z. Let's look at the example. Let's say find the probability of Z more than 1.41. So more than 1.41, where is the shaded region? So normally we can draw the shaded region as a guideline to find the probability value. Why? Look at here. Normal table, standard normal table based on smaller region. Left side or right side, same value. Because normal is symmetrical. Okay, so this one is 0. Right side, positive value. Left side, negative value. So where is 1.41? Positive value. So right side. Let's say the symbol like this. Equal sign. So the line should be like that. Okay, so back to the original example. Z more than 1.41. So the symbol here is greater than or more than. So the shaded region to the left of 1.41. The smaller region, same as here. Therefore, you can read direct from the table. So this one, exact value, 1.41. So where is 1.4? Here. And then second decimal is 0.01. Therefore, the probability value equal to 0.0793. Second example, z less than negative 1.41. So this one is negative 1.41. The symbol here is less than. So less than means that to the left of negative 1.41. So you can read direct from the table. Ignore the negative sign. Therefore, same answer as first example, 0.0793. Same value here. Same value 1.41. But different sign. Positive and negative, and different inequality sign, more than and less than. Let's try another example. Let's say you need to find the probability of z in between negative 1.41 and 1.41. So negative 1.41 is here, and then 1.41 here. So where is the shaded region? In between the two numbers. So here is the shaded region. So what is the probability value? Basic concept of probability value must be exactly equal to 1. Therefore, you need to find the value here and right here. So this one is 0.0793, same as here, 0.0793. Probability value always in positive value. Therefore, 1 minus 0.0793 and minus 0.0793. So the final answer equal to 0.8414. So this one, how you want to read the standard normal table. Let's try another example on how to use standard normal table or Z table. First question, Z greater than 0.86. So let's say you want to draw the shaded region. So here is positive value. 0, positive means to the right. So 0.86. Next step, look at the symbol. So the symbol here is greater than, means the shaded region is to the right of 0.86. Okay, next step, find the value of Z table. So 0.8 here. And then second decimal is 0.06. 1949. Therefore, final answer equal to 0.1949. Second example. Draw the shaded region. So here is 0. And then negative value means to the left. So left side, negative 2.02. Next step, symbol. The symbol here is greater than, means the shaded region is at the right side of negative 2.02. But the concept of Z table is smaller area. So this one. Find the probability value of negative 2.02. So negative 2.02 means negative 2.0 here, and then second decimal is 0.02 here. So this one is 0.02169. Therefore, the bigger shaded region equal to 0.97831. Third example. So where is the shaded region? Here is positive value 1.87. The symbol here is less than, means to the left. So same as second example, find the probability value of the smaller region. So 1.87, 1.87, 1.8, and then second decimal here is 0.07 here. So the probability value here is 0.0307. Therefore, 1 minus 0.0307 equal to 0.9693. Okay, let's try example 4. Z less than negative 0.16. So where is the shaded region? Negative value means to the left of 0. So here, negative 0.16. Next step, the symbol here is less than, means to the left of negative 0.16. So this one smaller region. Therefore, you can read direct from the table the final answer. So here is negative 0.16. So ignore the negative sign. Just look at 0.1. So 0.1 and then 0.06. So the final answer equal to 0.4364. Next example. Z greater than 0.87 but less than 1.45. So first step, find the shaded region. So the shaded region here, first value is 0.87, second value 1.45. Both number is positive numbers. Therefore, to the right side. So 0.87 and then 1.45. So the region is here. Okay. Therefore, what you need to calculate here is you need to find two probability value. First one is based on 0.87. Next one is based on 1.45. So 0.87, 0.87, 0.8, and then 0.07. Next value 1.4 and then 1.45 means 0.05 here. So the larger value minus smaller value. So the final answer equal to 0.1187. And then example 6. So example 6, both numbers, negative numbers. So negative numbers means to the left. So negative 0.24 and then negative 1.23. So this one is the shaded region. So same concept of example 5. Smaller probability value and then larger probability value. Okay, so find the probability value of each numbers or of each z values. So 1.23 So 1.23 is 1.2 and then 3. So 0.1093. Next is 0.24. So 0.24, 0.2, and then 4 here. So the final answer 0.4052 minus 0.1093, which is equal to 0.2959. So look at here, the probability value of 0.24. So 0.24 here, the probability value equal to 0.4052. Meanwhile, the probability value of negative 1.23 equal to 0.1093. So as close to zero value, the probability value getting larger. Look at here. This one 0.0 and then this one 0.5. Means standard normal table symmetrical. Here is 0.5 and then the other side is 0.5. That's why the basic concept of probability value must be exactly equal to 1. Remember that. Okay, so now you can try on your own to find the probability value for example 7, 8, and 9. At the end, you can check your answers. Let's proceed to example of case study. A study stated that the average weight of grains for a particular type of crop is 0.04 grams. Assume that the weight of grains is normally distributed and the standard deviation is 0.016 grams. So the keyword here is normally distributed. Therefore, X is follows normal distribution with mean. So this one is mean. Mean average. So mean equal to 0.04. And then variance. So variance sigma square. So variance based on standard deviation equal to 0.016. The standard deviation 0.016, therefore the variance equal to 0.016 squared. So first question, find the probability that the weight of the grains is less than 0.042 grams. So look at here, P means that probability. The symbol here is less than. So less than 0.042 grams. So this one, X transform to Z. So transform to Z, you will use Z equal to X minus mu over sigma. Therefore, substitute the X value and then mu also the sigma. Calculate. So Z less than 0.125. So where is the shaded region? The shaded region, positive value means right side 0.125. The symbol here is less than means to the left of 0.125. So where is the probability value of 0.125? So 0.1 here and then 0.025. You may use 0.02 or 0.03. Either one accepted, but you can calculate the most accurate answer, which is 0.4522 plus 0.4483 divide by 2. Okay, so the final answer equal to 0.54975. Next question. Calculate the percentage that the weight of the grains is between 0.025 grams and 0.04 grams. So, from X, convert to Z. Substitute X minus mu over sigma. Calculate, so Z in between 0 and negative 0.94. So where is the shaded region? So 0 here. 0. Then negative 0.94 to the left. Negative 0.94. So the shaded region is here. So where is the probability value of 0? 0.0. So 0.5000. Next, probability value of 0.94. So 0.9 and then 4. This one. Greater value minus smaller value. Therefore, the final answer equal to 0.3264. But you need to convert to percentage. Look at here. Calculate the percentage. Times 100. 32.64%. Proceed to second example. A gas supplier maintains a team of engineers who is available to deal with leaks reported by customers. The time taken to deal with reported leaks is found to be normally distributed with a mean of 65 minutes and standard deviation of 60 minutes. So this one, X is follows normal distribution with mean equal to 65 minutes and then the variance, so based on standard deviation 60. So that's why here is 65 mean, 60 square is variance. First question. Find the probability that the team will take more than 185 minutes to deal with the reported leak. So this one more than 185. Therefore, X is more than or greater than 185 minutes. The symbol used is like this. And then X transform to Z. So Z equal to X minus mu over sigma. Okay, so using this formula, transform to Z. Substitute X value equal to 185 and then mu equal to 65. The standard deviation or sigma value equal to 60. Calculate, so Z greater than 2. So where is the shaded region? So the shaded region, positive value. So here is number 2. And then the symbol here is more than. Therefore, to the right. So direct from the table 2.00. So where is 2.00? Here. So 2.0, the final answer equal to 0.02275. Question B. Find the probability that the team will take between 50 minutes and 1 to 5 minutes to deal with a reported leak. So same as question A, transform X to Z. So transform X to Z, calculate, so Z in between negative 0.25 and 1. So find the probability value based on negative 0.25 and then 1. You can draw the shaded region. So 1 to the right, here 1.00, and then negative 0.25 left side. So left side negative 0.25, the shaded region here between these two values. So find the probability values based on negative 0.25 and 1.00. So 0.25, the probability value equal to 0.4013, and then 1.00 here 0.1587. Therefore, the final answer equal to 0.44. Previous example, you have learned how to find the probability value or how to find the percentage value given the x or z value. If given the x value, you need to transform x using z formula, x minus mu over sigma. So this one, given the probability value which is equal to 0.28, and the unknown here is denoted by k. So how to find the unknown? You must remember this guideline. First guideline, if z less than k and then the probability value less than 0.5, therefore the unknown equal to negative value. Second tip, if z less than k and then the probability value greater than 0.5, therefore k is positive value. And then number 3, if z greater than k and then the probability value greater than 0.5, therefore k is negative value. And last one here is if z greater than k and then the probability value less than 0.5, therefore k is positive value. So you must remember here is less and then less. So k is negative. And then this one more and then more. K is negative. Meanwhile, if the symbol less and then more, k is positive. More and then less than 0.5, k is positive. Different sign, positive value. Same sign, negative value. Remember that. So back to the example. Z less than k, the probability value equal to 0.28. So this one less than. And then the probability value less than 0.5. Therefore, k is negative or positive? Same sign, negative value. So k is negative value. So from the table, if the probability value less than 0.5, you can read direct from the table. Okay, search. Where is 0.28? The nearest one. 0.28 here. 0.2810. So the value here is 0.5. Second decimal place is 0.08. Therefore, k equal to negative 0.58. Let's see. You want to check either your answer is correct or not. So k here is negative 0.58 to the left. So 0.58 negative. And then the sign here is less than. So less than means the shaded region is to the left of negative 0.58. Smaller or wider region, smaller region here. Therefore, you can read direct from the table. 0.58. So 0.5 and then 8. Is it 0.28? Yes. Therefore, K equal to negative 0.58 is a correct answer. Let's try another example. Probability of Z less than K equal to 0.975. So this one, the symbol here is less than. And then the probability value is more than 0.5. Different sign or same sign? Different sign. Therefore, K is positive value. Okay. In the table, is there any value exceed 0.5? No. So, you have to deduct this value. 1 minus 0.975 equal to 0.025. So, you can find the value of 0.025 in the table. So, where is 0.025? 0.25 here. 0.0250, 1.96. Therefore, K equal to 1.96. Why positive? Because different sign. Less than K but more than 0.5. Let's say you want to check. Okay, so where is 1.96? Positive value. So positive value, right side, 1.96. And then the symbol is less than. So less than to the left of 1.96. Concept of normal distribution is smaller shaded region. So here, 1.96, what is the probability value? 0.025. So here is 0.025. Therefore, here is 1 minus 0.025, which is equal to 0.975. Therefore, K equal to 1.96 is a correct answer. Okay, so now you can try on your own how to find the unknown. Please try these two questions and at the end, check your answers. Okay guys, let's try to solve this example. A synthetic fiber has tensile strength that is normally distributed with a mean of 75.5 kN and a standard deviation of 3.5 kN. The probability that a synthetic fiber has a tensile strength more than mkn is 15%. Find the value of m. So here we need to find the unknown. So what is the unknown? M here. And then what is the probability value? 15%. Convert to decimal, 0.15. Okay. So as usual, X is follows normal distribution with mean equal to 75.5 and then the variance equal to 3.5 squared. Okay, next, based on the information, X is more than M. So here, more than M equal to 15%. So look at here, the symbol is more than. and then the probability value is less than 0.5. So more and then less, different sign. Therefore, the unknown is positive value. Same sign, negative. Different sign, positive value. Okay, next step. From x, transform to z. X minus mu over sigma equal to 0.15. And then from this value 0.15, find in the normal table 0.15, the nearest one. So where is 0.15? Here. 0.1492. So where is the value of the unknown? 1.04. Positive value. Next step, solve the equation to find the value of m. Therefore, m equal to 79.14 kN. So is it correct answer? You can check. Okay. Where is the shaded region of 15%? So 15%, the shaded region based on the value of 1.04. So 1.04 positive value, right side 1.04. Then what is the sign? More than. So more than means to the right. So this is the shaded region. So from the normal table, 1.04, 1.0 and then 4. So this one, 0.1492 approximated to the 0.15. Therefore, m equal to 79.14 kN is a correct answer. You can try to do this quick chat question and you can check the answer. So this one, normal distribution as an approximation to the binomial distribution. So look at here. The original question is binomial distribution with two parameters and number of independent trials, and P represents probability of success. So normal distribution can be used if and only if NP and NQ are both greater than or equal to 5. So please remember these two conditions. So from binomial, discrete distribution, and then use normal distribution. So normal is continuous distribution. You have to apply continuity correction factor, means plus 0.5 or minus 0.5 or both. So look at here. First example, the original question, x equal to 5, so equal sign. For continuous or for normal distribution, we can't solve this question. So you have to apply the continuity correction factor. So therefore, plus 0.5 and minus 0.5. Like that. Second example, this one. X greater than 5. Means start from number 6. So when you apply normal approximation, this one becomes x greater than 5.5. Third example, at most 5 means including 5. So becomes less than 5.5. And last one here, this one. include 5 but exclude 9. So become like this. You have to apply continuity correction factor when you use normal approximation from the binomial distribution. Let's try this example. 40% of graduates are employed 6 months after graduation. If 400 graduates are randomly selected, find the probability that 170 or fewer are employed 6 months after graduation. So this one direct. So we know that this one is binomial distribution. 2 parameters and then the p-value. So this one and number of independent trial. Is it P? 40%? So look at here. After graduation. What you need to find is after graduation. Therefore, 40% is the value of P, 0.4. So is it suitable to use normal approximation? Let's check these two conditions. Okay. So first condition. NP. So NP 400 times 0.4, 160. So greater than 5. And then NQ. P plus Q equal to 1. Therefore Q equal to 0.6. Substitute NQ equal to 240, which is also greater than 5. Therefore, normal approximation is suitable to be used. So by using normal, you need to find the value of mu, the mean, and also the variance. So mean from binomial distribution equal to NP. And then the variance from the binomial distribution equal to NPQ. Therefore, X is follows normal distribution with mean equal to 160 and then the variance equal to 96. Okay, next step. Using standard normal table to find the probability value that 170 or fewer are employed 6 months after graduation. So this one. And then remember that from discrete and then you apply continuous distribution, you must use continuity correction factor. Include 170. So this one become 170.5. You plus 0.5. So from X here, transform to Z. So calculate Z less than 1.07. So where is 1.07? 1.0 and then 7 here. So the value of the probability equal to this one, 0.1423. Therefore, the probability value that 170 or fewer are employed 6 months after graduation equal to 0.8577. So this one, the example on how we use normal distribution as an approximation to the binomial distribution. Okay guys, that's all about the normal distribution and also normal distribution as an approximation to the binomial distribution. Assalamualaikum. Dah.